Welcome to our 5.8 half angle properties. All these formulas are on your green sheet and they will be available for you or available to you during the test or quiz. An important information here is the fact that you need to know how to determine the sign of sine, cosine, and tangent. In fact, the plus or minus is determined by the quadrant of 1/2x, not by plane x. For instance, if x is equal to 200, we know 200 is, well, you can figure out what quadrant 200 is. Knowing that this is 0, this is 180, 200 is located somewhere here. However, x is equal to 200, we need to know what 1/2 of x is. 1/2 x is equal to 100, and 100 is located in this quadrant. It's an angle in this quadrant where the cosine is the x value and it will be negative. The sine is your y value, it will be positive. Tangent being the ratio of sine over cosine, it will be negative. Let's do the same thing for the next one. This time I have 480. Well, 1/2 of x is equal to 240. What is 240 degrees located? 240 is past 180 but less than 270, so it's located in this quadrant. Being in this quadrant, the sine is, let's start with a cosine. The cosine, which is our x value, is negative. The sine, which is our y value, is also negative. Tangent, the ratio of negative over negative, will give us a positive. Now, here's one good example. Given cosine of theta is equal to 15/17 and 270 is less or equal than 360, once I have this interval, I know that it is located in between 270 and 360, meaning in our fourth quadrant. So I'll draw my triangle here. Knowing that the cosine, which is the adjacent, is 15 and the hypotenuse is 17. Using your Pythagorean theorem, you can figure out the remaining part. But for now, that's not my concern. My concern is to find the exact value of sine 1/2 x and so on. Well, 1/2 of theta, theta being this one. So I'll mark this as theta. I will say 1/2 theta is therefore located not between 270 and 360, but between 135, which is half of 270, and half of 360, which is 180. So the location of 1/2 theta is between 135 and 180, meaning somewhere here. Now that I know the location of this, I can tell you that the sine, which is the y value, will be positive. This one will be negative, and this, of course, will be negative. Now let's go ahead and find the sine of 1/2 theta. Well, the sine of 1/2 theta, based on the formula on your green paper, is equal to the square root of 1/2 times 1 minus, the sine here is, well, 1 minus, I would say 15/17. Note that I'm using 15 here and 17 here, and it's all based on this 1/2 1 minus cosine of x. So this is the formula I'm currently using, and knowing that the cosine was given, I'm using this value for the cosine. So from here, all I have to do is simplify. This is equal to the square root of 1/2 times 1 minus 15 over square root of 17. That's 17/17, meaning 2/17. And this is equal to the square root of 17 on the bottom and 1 over that. You do not need to rationalize. I can take this as an answer. Well, you will keep going and you will find the cosine of 1/2 of theta. Based once again on the formula is 1/2 times. This one will be 1 plus 15/17. And if you go on, you will say this is the square root of 1/2 times 32 over 17, which is equal to, oh, I'm missing a negative here. I should have known sine is positive. Cosine, because of this negative, will be negative here and negative here. Therefore, my answer is negative, and the value is 4 over square root of 17. The tangent, of course, is the easiest one because it's just the ratio of sine over cosine. And in this case, it will be sine of 1/2 theta over cosine 1/2 theta. So for the tangent, I will say it is equal to 1 over square root of 17 divided by -4 over square root of 17. And my final answer is negative 1/4. Alright, let's move on to the next page. The next page, we try to prove that the tangent of 1/2 x plus cotangent 1/2 x is equal to 2 cosecant of x. So I will start by rewriting the side that I'm picking. I'll pick the left side in this situation. So I will say tangent of 1/2 x plus cotangent of 1/2 x is equal to, well, tangent of 1/2 x is 1 minus, I'm getting this from your green paper again, 1 minus cosine x over the sine of x, plus the cotangent of 1/2 x is 1 plus cosine x over sine of x. Well, if I combine this, I will have 1 minus cosine plus 1 plus cosine. I will just have 2 on top because the cosine will cancel, and over sine of x. And 2 over sine of x is equal to 2 cosecant x. Alright, let's do this last one. The last one is a little complicated because it looks a little messy, but we can work on that. The top one is, I will start by rewriting it by cosine 1/2 x minus the sine of 1/2 x over cosine of 1/2 x plus sine of 1/2 x. Well, to work this one, I'll multiply by the conjugate of the bottom, which is cosine of 1/2 x minus sine of 1/2 x over cosine 1/2 x minus sine of 1/2 x. And here is, I'm doing multiplication. Note that I'm doing it because I have a fraction, and a single fraction, as I mentioned before, always work with a conjugate. But I will say this is equal to, if I distribute this, I will have cosine square of 1/2 x minus 2 times the sine of 1/2 x times the cosine of 1/2 x plus the sine squared of 1/2 x. And on the bottom, by the way, I use the a, this one for this, I use a minus b squared is equal to a squared minus 2ab plus b squared. For the bottom, this is a plus b, a minus b, and I'm going to set it to equal to a squared minus b squared. So for the bottom, I will say this is cosine squared of 1/2 x minus the sine squared of 1/2 x. At this point, I will say this equal to cosine squared of 1/2 x plus sine squared of 1/2 x is 1. And I still have the minus 2 sine of 1/2 x cosine 1/2 x over, I'm looking at my answer, I need 1 plus sine squared. So what I'm going to do here, I will transform one of them into the other. What I'm going to do is transform all into cosine. So I will say cosine squared of 1/2 x minus 1 minus cosine squared of 1/2 x again. So on top, I will have what? Note that 2 times the sine of 1/2 x cosine 1/2 x. It looks like my double angle. So this is 1 minus actually the sine of 2 times 1/2 x. And on the bottom, I will have 2 times cosine of cosine square of 1/2 x minus 1. Well, this is equal to, I have 1 minus sine of 1 minus sine of x over, here I have 2 cosine squared of 1/2 x minus 1. This is actually cosine of x. Once I reach this level, if you note on your answer, I have 1 plus sine of x on the bottom. So I need to introduce that 1 plus sine of x. What I will do is I'll multiply the top and bottom by 1 plus sine of x. And once I multiply top and bottom by 1 plus sine of x, I will have it equal to, well, I have again a difference of 2 squared, so it's 1 squared minus sine squared of x on top. And on the bottom, I will have cosine x times 1 plus sine of x. This is equal to 1 minus cosine squared of x. 1 minus sine squared of x is cosine squared of x over cosine x times 1 plus sine of x. I can simplify. I will take away this power along with the cosine of x. So my final expression is cosine of x over 1 plus sine of x. Let's check. And I think I reached my destination. I know it's kind of complicated, but you can do it too. I believe that's it. Yes.